had a working drive base. You can see how it's basically the same as we left it. What we're going to do now is we're going to create an electrical board. We're going to try to work on some bumpers if we have time. And we're also going to characterize the drive base in terms of these density properties so that we can get the weight of the drive base instead of just parts that have no weight. And this will allow us to make sure we're not overweight, and it'll also help to determine where our center of gravity is, and that's very important if you're making a tall robot or if you're making a climber. We're going to start by going to each of the parts, and we're going to click on them. You can see up here we have the materials. We're going to change the materials using this Autodesk material library, and we're going to change it to aluminum. This is aluminum 5052, I believe. So now we're going to do our gearboxes real quick. And we don't need to do the weights of small stuff like these bolts and these nuts here. That's pretty pointless. I don't really think it helps to accurately model the weight of the object. So these aren't actually aluminum 6061, but the best way to, the closest density material to what's inside these sim motors is actually aluminum 6061. So we're just going to go with that for our purposes. Always save, constantly save. You don't want to lose your progress. Now for the wheels, we're going to do these hubs, we're going to do these pulleys, and we're going to do this larger overall wheel here. So we can actually check density of certain objects by clicking on them, going to the eye properties on the drop-down menu, and then going to physical. Now we can update this here, and we can see that the pound mass very closely represents what the published value is on the Andy Mark website. So now everything should be characterized in terms of its material characteristics. So you can see the wheels are done, these plates are done, the motors are done. And so now, if we click on the entire assembly and go to eye properties, physical, update, you can see that we can estimate that the mass of this object is about 25 pounds. And that's when you include all the sim motors and stuff. And that's going to be a little bit off from what it actually is because we have omitted some of the hardware and some of the stuff that goes into this that would add a lot of weight. But it's pretty close to the published values of the AM14U3 on AndyMark and other, and sort of like the weight that your robot's actually going to be. So now that's done, we're going to start to make our electrical board here. So the electrical board is probably going to go somewhere over here. It's going to stretch from the back of this end plate or somewhere around there to about up to here. If you're making a cut in your chassis, that will change things. If you're not, you can use this entire space for your electrical board. But for now, I'm just going to keep it conservative and use this space that I've got in the back here. So I'm just going to make the plate rectangle here. It's 0.12 inches thick, so now we're going to characterize it as clear polycarbonate, because that's what it is. It's perforated polycarbonate. For the holes, you might notice that this is actually, the holes will start at this corner, because that is where I measured from. But we're going to need some more material around the edges. But we can add that later once you've finished adding your holes and making sure it fits properly. So the way I'm going to go about doing the holes is I'm going to make a sketch. I'm going to make a point at that bottom corner. And then I'm going to just finish. And then I'm going to use the rectangle pattern after I make a hole to expand it out across the entire object. So I click the rectangle pattern, I click the feature, which is the hole. I'm going to click aside, so that's the direction I want it to go in. And then I'm going to click the other direction. That's the other direction I want it to go in. I'm going to reverse both. Oops. Now, see, the issue here is that the holes, it's just copying this part of the pattern. I wanted to create the whole entire hole, so I'm probably going to restart now, considering that I messed that up somewhat. So that'll be 24, because I want to have a 1/4 inch. I want to have a little bit of spacing right here so that there's no interference. And then the next one will be 16 plus a quarter. Oh, 16 plus a half, I'm sorry. So 16 and a half by 25, was it? 16 and a half by 24. Putting it in the right place relative to what the holes are going to be placed in. My real issue now is that I need to make sure all the holes are in the right spots on my final product. So when I'm giving this drawing to people, it makes sense how to machine it and how to construct it. You can also see that these gearboxes are creating somewhat of an interference. We're going to make a cut here to actually deal with that interference and fix that. So now all we have to do is create a point, put it 1/4 inches from either edge, and then do the whole pattern with the rectangle tool. Choosing my directions, reversing them, choose the next direction, reverse that one, and that's good. We're going to change the spacing to 1/2 inch, and then we're going to change the instances to however many it takes to fill up the entire board here. That looks good for 33. And then that looks good for 48. All right, that looks good. I'm going to see how it looks in the assembly. All the holes seem to match up quite nicely, actually. Yep. Is the electrical board interfering with anything? Does not seem to be. So that's the board for right now. What's probably going to happen in not too long is we're going to put the battery somewhere back here. We're going to use the Andy Mark battery attachment case, which they provided us. We're going to make a cut in this electrical board to do that. We're also going to make some cuts for the gearboxes here, and then we're going to start placing our electronics. For example, the Roborio might go in this section. We might put the PDP here. We might put some motor controllers, some talons, or some Rev Sparks, and we might put the VRM and the router here. But that'll be for next time.